Hi, so this is the last video with regards to water that we'll be doing. Um, so the next part is about water measurement, and then after this we're going to do water quality. So water measurement is important for the planning, evaluation, and control of water usage. So what we are doing is we are measuring the amount and the rate of the water, and there are different ways in measuring the water rate or amount, and the methods that we use will depend on the flow rate, the conditions under which measuring is done, and the accuracy required. So when we are measuring water, and especially the flow rate, we'll write it down in liters per second, or cubic meters per second, or if it's moving at an extremely high rate, as you can see there, cubic meters per hour. So one of the ways that we can use to measure water flow is what's called a weer, in Afrikaans keerwalle. And here's a picture just of how it looks. So the water will flow down in this direction, and in the river or the canal, there'll be a structure like this that is in the way of the flow of water, so it's perpendicular to the direction in which the water moves. And this thing is very helpful for a number of reasons, but one of them being measuring the flow rate, or the rate at which the water is moving. So we've got three different types. You've got your rectangular, which is this one. You've got the Cipolleti, and then the V-notch. And this V-notch is used when you want to accurately determine the flow rate, and then these two are used for water diversion. So just if I can sketch a side view of how it looks and give you this picture again. If this is your river, maybe that should, okay, so this is the river and it's moving in this direction. So this is the direction that the water is moving in. Then your weir will be constructed over there. And then what happens is the water continues to move, and because the water continues to move, the level of your water actually rises. So if I can do this. So what happens then is that where it was here, the water level rises, and the water level will get to that place. And so then the water will go over the top, and we can easily then measure the flow rate of the water. I know in some instances, what they'll do is they'll put a bar like this, and it will be like a ruler or used to measure. And if when they measure the height of the water level, that's how they determine the flow rate. And then the other big ways of measuring the flow rate is volumetric and gravitational. And so this is just a very simple way of measuring the flow rate. If volumetric, how you can think of that is if you take a bucket and you take a pipe that has water in it. So what happens is you have water flowing in a pipe, and you've got your bucket, and then as soon as the water starts flowing into the bucket from the pipe, you'll measure, or you'll start the countdown, and you know the volume of the bucket. So when this bucket is full, you'll stop the timer, and then you'll say the volume of the bucket divided by the time it took to fill this bucket, and because you have the volume and the time, you can then easily measure the flow rate of the water coming out of that pipe. And so the gravitational is the exact same thing, but that is also just 1 kilogram of water equals 1 liter. So if you know the weight, you'll know the volume of water. Okay, so here's a sum. You have a dam, and so the diameter of the dam is 20 meters. The level lowers by 200 millimeters in 2 hours, 26 minutes. Determine the volume of water used. Okay, so you have a dam. Let's sketch it like this. And the diameter of this dam is 20 meters. So it says that the amount of water used, so after the water has been used, the level of the dam lowers, and the amount of water used is 200 millimeters. So they want to know how much water is used. So the volume of that water would be this area multiplied by that height of 200 millimeters, and so that is pi diameter squared divided by 4 multiplied by the height, and that you write out in this way. So it's that 20 squared divided by 4 multiplied by 0.2, because this is in millimeters and that was in meters, and that'll give you an answer of okay, so that'll give you an answer 62.83 cubic meters. So if you want to know the flow rate that the water was moving at when it was moving out of the dam, you'll take this 62.83 and you'll divide it by 2 hours and 26 minutes. So that'll be 60 minutes in an hour, so that's 120 minutes, plus that 26 is 146 minutes, and your answer will be 0.34 cubic meters per minute, which you can then convert over to seconds or in complete hours if you want to. And then lastly, water quality. So when you're looking at the quality of the water, if you want to irrigate, maybe 3 things mainly that you look at is the physical impurities, the organic impurities, or the chemical impurities. And when you're looking at the quality and the chemical quality of the water, the total dissolved solids is important. So the total dissolved solids refers to especially the salts in the water, and sodium absorption ratio. So total dissolved solids, that TDS, is related to the EC, the electrical conductivity of the soil. Then we're looking at sodium absorption ratio, so that's the amount of sodium, calcium and magnesium elements available in the soil water. Your toxic substances, that is sodium, chlorine and boron. So if you've got a lot of that in your irrigation water, you would rather not irrigate with that water due to the low quality of the water. And then pH, and pH is a measurement that's usually not used that much for irrigation water, because soil has a big buffer capacity, so that usually doesn't play that big a role. But then pH is also something you look at when measuring the water. So the water is tested once every 5 years. And it is also important to remember when you have a dam on your farm and you want to get a sample of water to send to the lab, it's always important to walk deeper into the dam. So do not sample at the edges or in the shallow water. You'll usually go in a deeper part of the dam to collect a sample of water. And saline water harm. So salinity is salt, a high salt content in your water, and it's important to know the salt content in your water. As right at the beginning of this module, we spoke about how harmful it is to plants, the effects salt has on the soil, and yeah, the root zone and your crops especially. And so back again to toxic substances as well. When you're doing an assessment of water quality and you want to know if it's toxic to certain crops or if it's going to be toxic to your soil, some crops can handle some substances a lot better and salts a lot better than other crops. So knowing your crop and whether or not your crop can handle the amount of salt is very important. So then all water should be under suspicion until water analysis is found suitable for use. Irrigation water should always be suitable for the crop, soil, and irrigation system combination. So that's system combination. If you have a drip system with a high calcium content, maybe, or bicarbonate content, what happens is that your line looks like this, and you've got very small holes for the water to actually go out of. So when you have precipitation that forms due to poor quality irrigation water, these holes will get blocked up and you won't be able to effectively use your dripper line or your irrigation system. So that's why it also plays a very big role in knowing what irrigation system you have and how to use your irrigation system. So this graph is used especially in the US, and sorry about that. And what it does is it is a way for us to classify the salt content and classify the quality of the water. So right here you can see C1, S1, and then C1, S2, S3, S4. So the S's get higher up this y-axis, and you can see C1, C2, C3. So the C value gets higher up the x-axis. So C refers to the salt content of the water. So if you have a high salt content, the C value gets higher. So up on this scale, your point will move in that direction, and the S value refers to sodium content. So higher sodium content in your water, you'll move up the y-axis, and that's how you can easily pinpoint what kind of water you have for irrigation. So you'll maybe be somewhere around here, and then what that says is if you are on the C1 S1 or C2 S2 scale, so if you are in these two values, then you have a high quality soil, irrigation water. C3, all these ones, you may expect some problems, and then these ones that are whiter are not suitable for irrigation. And that is the last this is the last lecture on water. I'll start with the next one later this week.